Let's see a few examples. To start with, let's consider the function f of x, which is x times the sine of 1 over x different from 0, or 0 when x equals 0. Okay, we have to define it like this because the sine of 1 over 0 is not defined. So we have to take care of that point separately. Okay, remember, we saw that the sine of 1 over x was this crazy function, okay, that was oscillating between -1 and 1. Remember? And it would start oscillating faster and faster as we were approaching 0. Okay, and this was not continuous. Was not continuous at x equals 0 because the limit was not defined. Okay, it's oscillating so fast and faster and faster and faster that the limit just does not exist. As x to 0 does not exist. Okay, but then you see that the sign is trapped between 1 and -1. Now that we multiply by x, the effect that is going to have on our function is going to create a different kind of trap. Okay, so we have here -x and x. Okay, and this is because the sign is going to oscillate between -1 and 1. So when the sign is -1, we'll have -x. When it is 1, we will have x. Okay, and then the function is going to be oscillating here between the two lines. And again, it will oscillate faster and faster as we approach 0. Okay, so here, the effect of these two lines is to concentrate all the oscillation into the point 0. Okay, so then that's the reason why we are adding this f of 0 equals 0, because then this one is going to be continuous. Everywhere. Okay. Now we are going to work at this carefully. Okay, first, this is very easy, but let me note it. The limit as x tends to 0, of course, is going to be 0 because if I take the absolute value of x sine of 1 over x, this is lesser, this is lesser or equal than x in absolute value, which converges to 0 as x tends to 0. Okay, here, if you notice, the two lines that I drew here, that is the plus and minus absolute value of x, okay, which is what we are seeing here. Here, we could look at this inequality as x sine of 1 over x in between negative absolute value of x and absolute value of x. Which are these two lines? Okay, so these two lines that I used to trap the function actually are these bounds here that I just used. Okay, so that is the reason why the limit exists. We have seen the same geometrically and algebraically. Okay, so yeah, continuity, check. And now, how about differentiability? Okay, now, when x is different from 0, no problem. Okay, we just need to use the product rule and the chain rule. Now, when x equals 0, that's a bit of a problem. That one we need to actually compute. So let's take the limit of f of x minus f of 0 divided by x as x tends to 0, let's say from the right, and see what happens. I don't want to be overly optimistic and start with the full limit, okay? So here we have the limit as x tends to 0 of f of x, which is x sine of 1 over x minus f of 0, which we saw, it's by the definition here, f of 0 is 0. Okay, so I can just not write it there. And then divide by x. And here we see what's the problem. So actually, let's just try to do the limit and see what happens. So the limit is going to be, after the simplification, the limit as x tends to 0 of the sine of 1 over x, which does not exist. Okay, so no derivative. It's not differentiable. Okay. But the story doesn't finish there. We could modify a little bit the function and say, okay, x squared sine of 1 over x, if x is different from 0 and 0 otherwise. So how about now? Okay, so in this case, notice x squared sine of 1 over x is going to be less or equal, because the sine is less or equal than 1, is going to be less or equal than x squared, but it's going to be bigger or equal than negative x squared, because the sine is negative 1 at the least. Okay, so that means that we can draw two parabolas here and here. And then here and here. Okay, so here we have our parabolas. And somehow let's use a different color. The function x squared sine of 1 over x is going to be oscillating between these two faster and faster as it approaches 0. Okay, but see what happens here. When you put the two parabolas, it's as if you were pressing the function with the fingers. Okay, see here, there is a triangular opening. Okay, and any line that passes, let's use some color here. We could pass through here with a line, and there could be different options for it. But if we try to pass through 0, 0 with a line, here we have only one option, which is the horizontal line. That's the only line that is going to fit in between the two parabolas. Maybe this color is not very visible. Okay, you see there? That's the only line that can pass through the two parabolas. And that is the tangent line. And we know that the slope of the tangent, this we know from calculus, is the derivative. Okay, so this is giving us the hint that f prime of 0 should be 0. Okay, and this is because the parabolas actually are kind of pressing down the function, the oscillation, until it's, well, differentiable. So let's compute that. Of course, it's continuous. the continuity, the argument is just as before, okay? It comes from this estimate. Now for differentiability, f prime of 0 would be the limit as x tends to 0 of f of x minus f of 0 divided by x. F of 0 again is 0. So we have the limit as x tends to 0 of x squared sine of 1 over x divided by x. And now we are good, because we saw before that the limit of x sine of 1 over x as x tends to 0 exists, and it's equal to 0, which is this was our guess for the derivative. Okay, so we were correct in our guess. Here there is something that is interesting to note, okay, which is that yeah, the derivative exists at 0, but it's not going to be continuous. So f prime of x is not continuous at x equals 0. How do we know that? Well, we just compute the derivative of x squared sine of 1 over x. We get 2x sine of 1 over x plus x squared times the cosine of 1 over x, and then the derivative of 1 over x, which is negative 1 divided by x squared. And there is this cancellation, which is a problem. And we have 2x sine of 1 over x minus cosine of 1 over x. But here, this limit does not exist as x tends to 0. For the same reason, the sine of 1 over x didn't have a limit as x would go to 0.